Hello and good afternoon. Welcome to the Safeguard webinar for Landlords and Retrofit Insulation webinar. We are now set to kick off. I hope everyone can hear us clearly. This webinar is an overlook at the new legislation and standards for retrofitting properties for energy saving purposes. It will also look into the different types of insulation and how they can be affected by damp. To introduce the people here, I'm Michael Pryor, who will be moderating, and alongside me is our laboratory manager, Clementine Walker, who will present the talk. It will take about 50 minutes to present. At the end of the talk, we have allowed 10 minutes to answer any questions. There is a link below in the YouTube description where you can submit questions during the presentation. Anyway, that's enough from me. Over to you, Clementine.
Thanks, Michael. Hi and welcome to Safeguard Europe's presentation on retrofit wall insulation and dampness, specifically for landlords. So I'm just going to go into talking about what minimum energy efficiency standards, or MEES, are, and the various legislation around this, including past 2035, the new retrofit standard, and also the Green Homes Grant, where there are grants available. So the second half of the presentation is really focusing on practical information. I'll do a very brief introduction to dampness, looking at rising damp, penetrating damp and condensation. We have full CPDs available on all three of these if you want more detail about those. And the main bulk of the presentation, I'll look at insulation and how this is affected by dampness. So we're focusing on cavity wall insulation, external wall and internal wall insulation. Okay, so why do we need to insulate? So the UK housing estimates suggest that energy use from domestic properties accounts for around 14 or 15% of total UK greenhouse gas emissions. So basically those household CO2 emissions from heating and hot water need to be reduced by 95% to reach our 2050 net zero targets. And there's a new target for all privately rented properties to reach an EPC of C grade by 2030. Okay, so why are we looking at the private rental sector? So from the government report published this year, private rental properties are among the least energy efficient in the domestic housing stock. They account for a disproportionate amount of fuel poverty. So 25% of EPC rated D to G private rental homes are fuel poor, compared to only 10% of the wider population. They represent some of the coldest homes. So on average, cold sort of rented homes are 2 degrees C colder in the winter than the most energy efficiency homes, which poses a risk to tenant health, and underheating obviously goes hand in hand with fuel poverty. They also contribute a significant amount to greenhouse gas emissions. So the whole of the private rental sector contributed around 11 megatons of carbon per year, but 9 megatons of that carbon comes from low energy efficiency rated properties, so below C grade. So you can see that the bulk of those greenhouse gas emissions come from those less energy efficient properties. And obviously that leads to a significantly higher energy cost. So how do we fix this? Obviously retrofit insulation is one of the best ways to fix this. There's still over 7.5 million solid wall properties with no insulation, and about 5 million cavity wall properties with no insulation. And even properties that currently might have insulation may need upgrading to better reach our carbon targets, which includes new housing being built today. So looking at the legislation in place to try and bring the UK housing stock up to standard and increase that energy efficiency, you have something called an EPC, which is an Energy Performance Certificate. And this is required for all properties available to buy or rent in the UK. And I'm sure you all know about these. Pretty much everyone will have seen one of these if you've bought or rented a house in the last 10 years. So this tells you the energy efficiency of the property. An A rating is the most efficient, which will have the lowest energy bills. So all privately rented properties in the UK must now have a minimum rating of E, and this is the landlord's responsibility, and this will increase to C grade by 2030. So what do landlords need to do? So basically from 1st of April this year, all rented properties, no matter the type of tenancy, must have an EPC rating of E or above to be lawfully rented. So if you're renting out a property with an EPC rating of F or G, then you're legally obligated to take steps to upgrade its energy efficiency. And one of the largest sources of heat loss in the building is through the exterior walls, up to about 35%. So most buildings in that G to F category will actually have improperly insulated walls, which is why wall insulation is one of the most popular methods of increasing energy efficiency in buildings. So just to warn you of this, there's a consultation at the moment. So currently there's a target for all privately rented properties to have an EPC rating of C by 2030. However, there's a consultation now which came out in September, which is proposing to bring this forward to 2025 and increase the amount of spend that will be required. So it's really worth thinking about these things and improving the energy efficiency of a property now while there are grants available. There's other legislation in place as well. So there's the Homes Fitness for Human Habitation Act, which came out in 2018. And one of the main parts of this was that it requires freedom from damp for rental properties. So in determining whether a house or dwelling is unfit for human habitation, freedom from damp is one of those. And essentially if a tenant or occupier perceives that the room, that the building is damp, then it is defined as having a damp problem. So by doing retrofit insulation, we previously have been doing a lot of retrofit insulation, and actually it's also led to its own form of dampness. So its recent forms have really caused widespread moisture issues. I think the most commonly known one is wet cavity wall insulation. There's lots of news articles about this over the last 10 years or so. You also have poorly installed external wall insulation, lack of ventilation, mold growth, things like guarantees not being honoured and companies going out of business. So this has led to damage to buildings and health issues for occupants due to mold growth. So this is something we really want to avoid repeating. So there's been lots of lessons learned from this. There was a BRE report which came out which found that evidence that cavity wall insulation or external wall insulation has been installed in unsuitable properties or without due regard for best practice. And then this led on to the Each Home Counts report, or the Bonfield report. The proposed solution to the above was to establish a quality mark for all energy efficiency and renewable energy measures and for all companies operating in this sector. So this led to the establishment of something called the Trust Mark and the creation of the PAS 2035 standard. So what is PAS 2035? So following Each Home Counts, this was created as a specification of how energy retrofits should be carried out and is required under the Trustmark scheme. So this focuses on a whole house approach to retrofit rather than individualised measures. This is to ensure retrofit is carried out appropriately for the building and risks of unintended consequences such as moisture issues are mitigated. So PAS 2035 introduces new roles, the most important of which is a retrofit coordinator, which will be necessary for all domestic retrofit. So these new regulations began 1st of January this year, with installers encouraged to become PAS compliant and Trustmark endorsed, and they will become mandatory from 1st of July next year. Okay, so one of the main things that PAS 2035 focuses on is moisture. So it requires that the building is first brought into a good state of repair before any energy efficiency measures can be installed. So before carrying out any energy retrofit, the building must be made moisture safe by establishing a safe dynamic moisture equilibrium through each building element and improving the resistance of the building envelope to moisture penetration. And I'll talk a bit about how to practically achieve that in the second half of the presentation. Okay, so this presentation really focuses on retrofit wall insulation, which is kind of the most common form of insulation that will be needed to upgrade your properties. So what PAS does is it rates each energy efficiency measure from 1 to 3 on a risk score. So 1 is a low risk and 3 is high risk. You can see I've highlighted here the wall insulations. So all of these come with a 2 of moderate risk, other than internal wall insulation, which has the highest risk of 3. So this really is considered the riskiest type of insulation, but is the only practical option in many circumstances. And I'll go into why that is later on. Okay, so just a brief bit about the retrofit coordinator. Essentially, this is the person who will be responsible for overseeing the assessment of the dwellings and also all of the subsequent specification monitoring and evaluation of the energy efficiency measures that have been put in place in accordance with PAS. So this is a necessary role for domestic energy retrofits to comply with PAS 2035 and Trustmark. And there are currently training courses for people to get up to speed on that. Okay, so just a brief few slides about the Green Homes Grant, which is available at the moment. This is a great scheme to get involved with if you can. It is a grant of up to £5,000, which will allow you to cover primary measures of solid wall insulation, underfloor insulation, cavity wall or roof insulation. It also covers fuel efficient like ground source heat pumps and air source heat pumps, as well as solar thermal power. So really like low carbon heating and insulation are the only things covered by this. And you can also install secondary measures if you do one of those primary measures. And the installers must be Trustmark approved and be working to the PAS specification. So the Green Homes Grant comes with additional services that the voucher will cover following PAS 2035 and looking at really focusing on this whole house approach. So one of the things it will cover is a damp specialist, as well as repairing and treating damps, which is reasonable enabling work to support the retrofit. So it's really looking at that concept of bringing the property into good repair before installing your energy retrofit measures. Okay, so how to apply? It's really easy. You go onto the Simple Energy Advice website, you fill in details about your property and it will give you recommendations for suitable energy efficiency measures. Then you can look up a list of Trustmark approved contractors to contact and you can get quotes from them to carry out the works. Okay, so now I'm going to focus on the second part of the presentation, which is really the practical elements of how to avoid pitfalls with insulation. So I'm just going to do a really brief introduction to dampness. So essentially there's three main sources of damp. There's rising damp, which is groundwater that rises through the masonry from the ground. Usually happens if you don't have a DPC. There's penetrating damp, which is from wind-driven rain, which penetrates into and through the masonry. And then there's condensation, which is water generated inside the building. Okay, so really briefly looking at reasons for rising damp. So either an older property, such as a solid wall property, which likely has no DPC installed in the first place. It was built before building regulations required this. So this requires a remedial DPC. The other reason for rising damp is in a newer building that did have a DPC, that may have subsequently become bridged due to building work such as increasing the ground height externally. So it's possible to rectify this without installing a new DPC, but you can also install a new DPC if it's necessary. Okay, so one of the things I'll talk about that really affects rising damp is the concept of evaporation. So something that can affect it is wall thickness. So the thicker the wall, the less surface area there is for evaporation. And also adding impermeable coatings reduces the evaporation required, which can increase the height of rising damp. So a really simple way of thinking of rising damp is this balance between the capillary moisture available in the ground rising up and the amount of evaporation available. So the more evaporation you have, the less water you'll have in the wall, and the less evaporation you have, the more water you're going to get in your wall.
So just on this sort of rising damp situation that you're talking about, it's quite common, especially for it to appear, and most kinds of like dampness, especially after you've done some form of renovation work or even retrofitting, because you've effectively changed the wall structure and the sort of permeability of the wall.
Yep, you've either bridged it or changed the evaporation or how the dynamics of that building element are working. So it's really the time when you'll see issues with rising damp, if you didn't already have them. Okay, so now looking at penetrating damp. So this is caused by ingress of water through external walls and roofs. It's due to heavy rainfall and wind-driven rain. And one thing to bear in mind is exposure zone map. So this goes from 1, which is very sheltered, so not too much wind-driven rain, to 4, which is very severe, which means very severely exposed to wind-driven rain. And depending on which area of the country you're in, you're likely to have more or less issues with penetrating damp. So visual symptoms of penetrating damp are decorative spoiling to the inside wall, musty odour, mold growth, blistering paint, things like that, that typically don't have a tide mark, which would indicate rising damp, but instead are all the way up the wall, and found much higher and possibly in second floor rooms. So this picture here is actually penetrating damp caused by retrofit cavity wall insulation, which is why it was so severe. So the primary paths of rain penetration are through porous masonry materials such as bricks and mortar, or through masonry defects such as cracks or gaps in the structure. Okay, and finally, condensation, very important when talking about retrofitting. So essentially, the concept boils down to warm air being able to hold more moisture than cold air. So if you take a room that was at 25 degrees C and has a set amount of molecules of water in it, it will start at about 42% RH. As we drop it down to 15 degrees C, we have the exact same amount of water in the air, but the amount of water that the air can hold has gotten smaller, or the cup has gotten smaller, until eventually you drop down to a point below the dew point. Here it would be 5 degrees C, where the cup can no longer hold that amount of water, and the water spills over and turns into liquid water and condenses on surfaces. So why does our air contain moisture? Basically just by people existing create moisture, and it's a very natural thing for people to do, like sweating and breathing create moisture, cooking, bathing, washing clothes and drying clothes indoors. All normal things that people will do will generate moisture inside the house. So ventilation really is key. So lack of ventilation is a common cause of condensation and mould. Retrofit of energy efficiency measures such as new windows, insulation and air tightness measures greatly decrease the amount of natural ventilation in homes. Therefore, it's necessary to install ventilation measures alongside energy efficiency measures to reduce moisture risk. Okay, so let's have a look at cavity walls to start with. So cavity walls are the most widely used in the UK since 1920. Out of about 28 million homes in the UK, 20 million of those are made with cavity wall construction. And this is typically a really robust construction against rain penetration when it's left unfilled. So they were actually originally intended to protect against rain penetration. So rain will always pass through this thin outer leaf, but in an unfilled cavity, it should just drip down the inside face of the inner leaf and not pass of the inner leaf and not pass to the internal wall. So that's why you have things such as cavity trays and weep holes to safely funnel the water away from the internal face of your building. However, more recently, cavity walls have been seen as a really good place to fit insulation. So as of December 2018, about 14 million homes had cavity wall insulation, which is about 70% of all homes with cavity walls. So there's about 5 million left, 4 million of which are easy to treat standard cavities, and the rest are kind of more complex, less standard cavity wall properties which may have faults and defects. Okay, so cavity wall insulation and dampness. So cavity wall insulation is a really great cost-effective way to insulate walls. However, care needs to be taken when considering the condition of the external leaf. So the biggest risk when installing cavity wall insulation is from penetrating rain. And these are various moisture paths that are available when you've put cavity wall insulation in your wall, depending on the type. So foam fills can create perfect pathways where the foam separates out. Particulate fills as well, when they sink down, can create voids where moisture can pass through, as well as fibre fills. Again, if that condenses down, it's the perfect pathway for moisture to get across. So how do we avoid these pitfalls? Only properties with a cavity wall gap of greater than 50 millimetres should be filled as standard, and repairs to the external face should be carried out prior to cavity wall installation to ensure it's fully weatherproof. So this includes things like repointing, filling cracks, repairing rainwater goods, all of that kind of stuff. and also consider the use of a masonry water repellent, which can protect cavity wall insulation against the effects of penetrating damp. So they can allow the use of cavity wall insulation in properties which may otherwise be unsuitable, for example, where you have very porous or sport bricks present. So one that we provide is Storm Dry Masonry Protection Cream. This is a colourless, breathable water repellent, keeps the original appearance of the substrate and allows the wall to breathe. It's a cream formulation which allows much deeper penetration than liquids, and it's been BBA approved for 25 years. So we did some testing at Lucidian, and they built a single skin brick wall which represents that outer cavity leaf, and we applied Storm Dry to two parts of it, these two here, and the central piece we left untreated. And then they exposed this to rain, and Storm Dry led to a reduction of 95% in the water absorption of the wall. And you can see here from the infrared camera that the parts treated with Storm Dry are much warmer than the parts not treated with Storm Dry. So it made a big difference in the rain penetration. It also improves the thermal resistance itself. So dry bricks have twice the thermal resistance of saturated bricks. So using Storm Dry can help keep the thermal performance of your wall, as well as protecting your cavity wall insulation. So if you install cavity wall insulation into a property but it becomes damp, it's actually not doing its job of insulating. So before cavity wall insulation, a cavity wall has a U value of about 1.6. The lower the U value, the better the insulation. So if you put blown fibre insulation in but that gets damp, you actually haven't really improved on that U value very much. So you've only gone down to about 1.2. Whereas if you keep that cavity wall insulation dry, such as with something like Storm Dry, you're getting much better thermal performance, and that's making sure that you're keeping the maximum performance of your product and getting your insulating value. So one thing to bear in mind is obviously you don't want to trap moisture in the wall. So Storm Dry is fully breathable. It had little effect on the vapour diffusion of the brick substrate, so will allow your wall to dry out. So we did a case study of a property locally to us. This was a council property that had cavity wall insulation installed but became very damp and had lots of issues. So we removed the damp cavity wall insulation. We then applied the masonry waterproofing cream and did localised repointing, allowed that wall to dry, and then installed new cavity wall insulation 9 months later. And this really completely stopped the issue, and they haven't had issues since. So one moisture safe way of installing cavity wall insulation is to use Storm Dry Masonry Protection Cream alongside necessary repointing works to protect your cavity wall insulation. And this would offer a moisture robust strategy to do insulation. Okay, so now I'm going to talk about solid walls. So these are typically found in pre-1920s properties. There's around 8.5 million properties in the UK with solid walls, and they're much more vulnerable to penetrating rain due to lack of a cavity. So most often also these properties were built without a DPC, so rising damp can be an issue. So looking at solid walls and penetrating rain, there's no cavity there to prevent rain from making it to your internal face. And typically if you've got drying and wetting patterns where you have enough drying, water won't make it through to the internal face. However, during periods of persistent rainfall, that wall can become saturated and you can have issues with penetrating rain, such as the storms we've had recently. In fact, due to climate change, we're actually getting much more periods of persistent rainfall in the winter, much more wetter winters. So that is something to be more wary of. Okay, so solid wall insulation. As of December 2018, only 9% of homes with solid walls had insulation. So still over 7.5 million solid wall properties with no insulation. And that's typically because solid wall insulation is a bit more tricky to install and is typically more expensive. So there's two main ways of insulating solid walls, either externally or internally. And both of these come with pros and cons. So this property here has both. On the side face, which didn't need to be conserved, we could put external wall insulation on. However, the front face of this property was needed to be conserved for heritage reasons, so internal wall insulation was used there. But basically, external wall insulation will change the appearance of the building, may not be allowed due to planning regulations or conservation issues, whereas internal wall insulation will often result in loss of floor space. Both of these insulation types can lead to moisture risk. Okay, I'll start with EWI. So the biggest moisture risk when installing retrofit EWI is exacerbation of rising damp. So if you think about that moisture balance where it's a playoff between capillary moisture from the ground and evaporation, by putting EWI on the external face of your wall, you're massively reducing evaporation. So one thing that the Energy Saving Trust highlights is that the main damp issue to be avoided with external wall insulation is rising damp. So if you already have a problem with this, then it will need to be fixed before the insulation is fitted. Otherwise, you run the risk of trapping damp inside the wall and making the problem worse. So really, installation of retrofit EWI can result in pre-existing rising damp becoming worse. And also, properties that did not have visible issues with rising damp before EWI can develop problems after installation. This is due to reduced evaporation. So say this is your property without EWI, you've got a low level of rising damp, maybe you've never noticed it, you don't see it. You suddenly put EWI on, reduce your evaporation, you're driving that rise of damp higher to a point where you may start noticing it. So it's really important to fix that before you install EWI. So just ensure the condition of the wall is surveyed prior to external wall insulation being installed. If there isn't a DPC present, you need to carry out any necessary remedial works prior to installation. If the wall is significantly damp, it's recommended to allow time for this to dry out after remedial work and prior to EWI installation. And always consider the use of vapour open internal wall finishes, such as renovation plasters, vapour open paints, etc., to allow that evaporation to still occur, obviously to be used in combination with good ventilation. So we have a lot more information on retrofit DPC installation, lots of it available online. We have a booklet which is freely available, so if you want to read up on that, I recommend it. One thing to say is that the Solid Wall Insulation Guarantee Agency does require proof that a DPC has been installed in order to get your guarantee. So they require photos of that to make sure that you have the minimum requirements for EWI. And just to finish up, briefly penetrating damp and EWI. So well-installed external wall insulation can actually really protect against penetrating damp. It's a really good protection. But poorly installed EWI can allow rain to penetrate and obviously trap it by inhibiting evaporation. So the BRE, the study that they found, quality of design and installation of EWI was usually quite poor, especially with detailing, probably due to unreasonable cost expectations and it being carried out too quickly. So if you are getting EWI installed, make sure you pay attention to the detailing and get that right so that you don't trap penetrating rain behind your EWI. Okay, so a moisture robust EWI system kind of looks like this. We make sure you install it correctly so you're not getting penetrating rain, and then install a retrofit DPC using either dry rod or dry zone cream. Okay, so now to look at internal wall insulation. I've saved this for last. It is the most complicated. So IWI is installed internally in the building, leaving the exterior unchanged. So it's a great option for period properties to maintain the characteristic facades and can be really unobtrusive when installed correctly. So this is a property, Georgian Townhouse in Bloomsbury. That's a really good example of how to do retrofit correctly. So you can see this is after the retrofit. You would not be able to know that this had been energy retrofitted. They used internal wall insulation here and basically worked very, very well. So with internal wall insulation, the biggest risk is from penetrating damp. It's deemed as the riskiest type of retrofit insulation due to this. You may remember that table from past 2035 I showed at the beginning, it had the highest risk of 3. And that is entirely due to moisture building up at that interface between the internal wall insulation and the external wall. So basically, penetrating rain can seep into the wall and collect behind the insulation, leading to issues with mold growth and damage to the insulation. So this was a property that had IWI installed badly. After a few years, it was taken down and loads of mold was growing behind the insulation. What we did was a case study actually on this property with IWI and using brick cream, or storm dry cream, as a way of making this a more robust situation. So external wall insulation was installed on the side of the building, but EWI wasn't suitable for the front face. As you can see, it's quite a characteristic facade, it needed to be maintained. So IWI was installed. There were very old and damaged bricks present, which have very high absorption. So internal wall insulation was installed with data loggers to monitor the moisture content in that wall behind the insulation. And this is a model of like what we predicted would happen. So here you can see the dark green line is the wall without any brick cream, and the light green line is the wall with brick cream. And you can see the light green line stays below this 80% risk of mold growth line the entire time, whereas the wall not treated with brick cream can become damp and you get a risk of mold growth in certain seasons. So the real measurements actually showed this as well. In fact, they had much better than even the model had predicted. So this was the area that was treated with storm dry, and this is the area that wasn't. So this blue line is the untreated brick, and it had a much higher moisture content in this danger zone for mold growth, compared with this green line, which was the storm dry treated brick. This had a much lower moisture content throughout the years and throughout the seasons, basically remained in this green safe zone where mold would not be an issue. So more recently, there's actually some government research been published, this was last year, which used WIFI modelling to determine risk of moisture damage to buildings for different retrofit insulation measures. And solid walls with IWI were considered one of the most risky retrofit build-ups as part of this study. That's where the data came from for the past 2035 risk assessment. So basically what they found was that all of the modelled IWI cases failed due to high levels of moisture build-up. The main source of moisture was found to be penetrating rain. So in all the exposure zones, when they modelled just putting IWI in a property, every single one failed because it became too damp. So they tried lots of different things in the model to try and bring this moisture down. And what they found was that the only additional measure that makes a significant enough difference to improve the status of the model cases is the addition of the brick cream layer. And we were lucky enough they actually used the data for storm dry in this report, just because we have so many reports freely available. And what they found was that in zones 1 to 3, using storm dry allowed each of the IWIs to pass and stay moisture safe. In zone 4, they determined it still failed. However, you can see from this graph, this is in Swansea zone 4, the most exposure zone. So the grey line is the IWI without brick cream, and you can see the water content in that wall becomes huge and also increases over time. Whereas with brick cream is the blue line, it maintained a much lower moisture content throughout the years. So how can you make your internal wall insulation safe? Basically, ensure the external wall condition is surveyed before any internal works begin. Carry out any necessary weatherproofing work, such as repointing, crack filling, repairing seals around windows, repairing rainwater goods, etc. You might want to consider testing the porosity of the wall substrate. So we have storm dry Carson tube gauges available if you did want to, and consider the use of a brick cream, which can massively mitigate the risk to IWI. And one last thing to talk about with penetrating damp and IWI is the risk of freeze-thaw. So insulating the wall internally can lead to colder temperatures on the external wall because you're no longer allowing the heat from the property into that wall. And combined with penetrating rain, this can lead to freeze-thaw damage to that external masonry. Obviously, at the moment, this is of more concern in Central and Northern Europe due to colder temperatures. However, the UK is experiencing more extremes of weather, so it's something to be concerned about going forward, and just making sure you have a robust strategy for IWI. Okay, so one last thing with IWI. So rising damp can be affected by IWI if you're using a non-vapor open system. So damp can rise above or move around the insulation, and the moisture content of the underlying wall will rise, which will reduce the overall insulation value and increasing that risk of frost damage and other types of degradation. So ensure rising damp is rectified before installing IWI, and consider the use of vapor open insulation as well as good quality ventilation. Okay, so just a brief practical interlude about how to do good IWI. So basically, IWI needs to be applied in very thick layers to achieve useful insulation values, which can lead to a lot of loss of internal room space, and can often require costly remodelling of internal features such as window reveals, doors, etc. However, more modern aerogel internal wall insulation allows useful levels of insulation to be achieved at much lower thickness. So aerogel is the most insulating material that we have. It has a much lower thermal conductivity than other types of IWI, which means you need to install much less of it to achieve the same insulation value. So it preserves the internal room space and also reduces installation costs because you don't have to do remodelling. So we have, ours is called EP board. It's a 3mm MGO board with 10mm aerogel blanket, which can be applied directly onto walls. We recommend this is combined with storm dry externally to maximise the thermal resistance of the wall and minimises the risk of interstitial condensation. So it improves the U value of solid walls by about 60%. It can take a solid wall from 2.1 to 0.8 with the EP board. So the properties of this is that we've got really, really low thermal conductivity. So aerogel has a 0.015 thermal conductivity. Most other internal wall installations will be around 0.5, 0.4. So it's massively reduced. Okay, so this is our sort of idea of what a moisture robust internal wall insulation system will look like. So you'll want to use storm dry masonry protection cream along with any repointing and necessary weatherproofing works to protect the external face of your wall, and then using a vapor open internal wall insulation system such as our aerogel blanket, and combined with damp proofing rods or a DPC if necessary, and this should offer a moisture robust strategy for IWI installation. Just briefly to show a case study of where this worked really well. So this was a solid single skin brick wall in West London. It had a very low EPC rating and problems with condensation and mould. The main source of the heat loss was found to be through the walls, and this was exacerbated by rain penetration at the back of the property. So external wall insulation was not possible due to planning permission, and traditional internal wall insulation was too thick. As you can see here, a lot of the rooms were very small and pokey. They didn't have the space to work with to lose when installing large IWI. So they chose the slimline EP board to minimise the loss of space. And storm dry masonry protection cream was applied to the external, the back face of the property where there was problems with penetrating rain, to protect that. So, storm dry EP board was installed. It's very quick and easy to install. You use an adhesive to stick it on the wall. There's a very thin profile, so there was no need to change the architraving or windowsills in the property, which meant that the installation went very, very quickly, and the installers were very impressed actually. And it can be skimmed straight away with standard board skim and painted using standard techniques. So U value measurements are ongoing. Before the treatment, the U value was around 2, watts per metre square Kelvin. After we build and storm dry, it's predicted to be about 0.8. And the significant improvement in U value will result in a much warmer and easier to heat property, and it will hopefully also reduce the chance of condensation and the mould growth issues. As another option, if you do have more space to work with, we recommend the use of insulating plasterboard, and we have a moisture robust system for this. So again, you'd want to use your storm dry protection cream externally, and then we have a dry grip adhesive and dry shield cream, which can be applied to the wall along with your insulating plasterboard. And this is a BBA approved plasterboard system for insulating walls. Okay, so I'm just going to do a really brief summary. Basically, retrofit of existing buildings can be very complex and needs to be carried out in a responsible way to avoid creating moisture problems. So retrofit of energy efficiency measures will need to comply with PAS 2035, which requires a retrofit coordinator to be involved. And for landlords, I'd really recommend that you get involved with the Green Homes Grant, get all the grants that you can, because the minimum energy efficiency standards really are going to get harsher and harsher, particularly by 2030 or possibly by 2025, when it will have to be a C rating. Sorry. Okay. Thank you for listening. So we do have other CPD seminars on all of those types of dampness. So we have basement waterproofing, penetrating damp, rising damp and condensation. So if you want to know more about any of those types of dampness, I recommend signing up to those CPDs.
Okay, thank you, Clemmy. That's a really good, interesting talk there. Got a few questions actually, if you want to spend a bit of time on these. Got a question here. It says, I have a damp wall which I want to sort out. How long should I wait for it to dry out before installing insulation and replastering?
So it depends on how damp the wall is. If you're talking cavity wall insulation, you want to apply storm dry, do all your repointing, and allow it to dry for as long as you can before you apply your cavity wall insulation in there. If you're insulating internally, you can get away with a bit more, because once you put storm dry on, you're not going to be getting more moisture at that interface. So really it depends on the type of insulation, but as long as you can is the kind of
normally
recommendation.
The idea is that you want to allow the wall to be open to the elements to dry out.
To dry out, once you've stopped the form of dampness that's causing the issue.
And then on like the internal wall, you want to basically leave that bare as well to try and allow it for. And if you do need to replaster, you try and leave that sort of not painted as well. Yes,
a vapor open plaster, a renovation plaster, and a vapor open paint if you do need to paint.
Okay, just another question here, just talking about the retrofitting. It says, how long does it normally take to become a retrofit coordinator?
So the courses online, I think they last 3 to 5 days. You can become a coordinator. There's obviously tests and things to do. You can also do it as a part-time learning from the AECB, which may take a few months, but the time spent on it is the same. It just depends how quickly you want to go through it.
So if you're a person who's going to be doing a lot of retrofitting in the future, it might be quite beneficial to become one of these retrofit coordinators.
Yes, it's a useful course to go on. It really teaches you all the building physics, a bit of the stuff we touched on today, and how to avoid all these pitfalls with moisture as well as air tightness, etc. And
also it means that you've always got one on site, so you can get a job done, basically.
Yeah.
I've just got one final question here. It's just talking about storm dry, saying, would you use storm dry for all cavity insulation jobs? Are there any houses or properties when it's not appropriate?
So that's a good question. So it really depends on the exposure zone that you're in, and also the local environment. So if you're on top of a hill but in exposure zone 1, then obviously you're going to be much more exposed than the exposure zone may indicate. There is a standard for determining how exposed your property is. So to be honest, I would recommend storm dry for any cavity wall insulation job, because if you're doing it, it's a quick and easy way to ensure that you're not going to have issues, and particularly if you're doing certain types of fills, like fibre fills tend to be more absorbent. Other types of insulation you may get away with, but really you want to be as robust as possible.
Yeah. So what you're trying to say is that you're trying to reduce any damp just getting in initially. So that's sort of like primary resistance is what you're aiming for that applying storm dry.
It's harder to fix wet cavity wall insulation after it's gotten wet than it is protecting it to start with.
Because it can sometimes, if you apply storm dry onto a wall that's got wet cavity wall insulation, it can dry out, but it takes longer anyway.
It will take a long time. Yeah, we do recommend typically to remove it unless it's the very mild case of dampness.
Okay, well thanks for those answers, Clem. It's really useful. Like I said, if you have any other sort of like in-depth questions that you want to send to us, you can send them via the YouTube description below this video. You can also send them to us via our email address, info@safeguardeurope.com, or you can send them to webinar@safeguardeurope.com. And if you want to sign up to any of our other webinars, just look on our website and you can find all the information you need. Okay, I think that's it. Thank you all for listening. Thanks. And have a good day. Okay.
Cool.